Have you ever wondered where does the formula for calculating the present value comes from? So this formula, the one that I'm showing. So, well, in this video, I will walk you through of how we derive this formula for calculating the present value. Well, the present value formula, which says present value equals to x into 1 minus 1 plus I to the power of negative n all over divided by I. Well, it is used to calculate the present value of a series of equal cash flows. So we will denote them as what? As x. So we're saying x, it will denote our uh, cash flows, or we would say equal payments. Equal payments. So now this formula it is used to calculate the present value of these equal payments over a period of n of time n. So now n it is our period of our payments. Period of payments. So now suppose that we pay this series of payments of x payments at the end of our time interval. So I'm going to draw a timeline here to demonstrate to you guys what we mean by this. So now we have a time period from time 0 to time n. So now this will be time interval 1, 2, 3, and so on. So now we are paying at the end of each time interval, we are paying a series of x payments. So now at the end of time period 1, we pay x, and at the end of time period 2, we pay x, and so on. And at the end of our n period, we also pay x. So now these are each payment in the future, well, it is worth less today due to the time value of our money, which states that a rent today is worth more than a rent tomorrow. So that's the time value of our money. So now this series of our payments, x payments, we will discount them using the discounting factor. So we will discount them using a discounting factor, which is equal to 1 plus I all over to the power of negative n, which is the discount factor for a single payment made at the end of n periods. So this is a discounting factor for a single payment made at the end of n periods. So now this discount factor tells us or tells you how much a payment of x made in the future is worth in today's terms. So breaking down this series of x payments, we have a present value calculated as follows. So now we are going to say present value equals to, so now the x payment made at the end of the first period, it will be x into 1 plus I. So this is for the first period, it will be negative 1 plus x, the one that is made at the end of the second period, it will be 1 plus I to the power of negative 2 plus x into 1 plus the one that's made at the end of the third period, I to the power of negative 3, and so on until the last payment, which is after n periods, so which is x into 1 plus I to the power of negative n. So now you can see that we have a common factor of x. So now we are going to factor it out. So it will be x into 1 plus I power of negative 1 plus 1 plus I to the power of negative 2 plus 1 plus I power of negative 3, and so on until 1 plus I to the power of negative n. Okay, so now we have this series. Well, remember that I, it is greater than, oh, it's positive, right? So now we know that 1 plus I, it will be greater than what? It will be greater than 1, right? So now if we say, or if we divide this both sides, it means if we divide this inequality by 1 plus I both sides, well, we are going to have 1 both sides, whereby it will be 1 over 1 plus I. So now this is the same as 1 plus I to the power of negative 1. So now it means this 1 plus I to the power of negative 1 is less than what? Is less than 1. So now, and on our series, this is our series, right? So now it means we will have a geometric series with a common ratio of 1 plus I to the power of negative 1. So now this is what I mean. So we have a geometric series whereby our R equals to 1 plus I to the power of negative 1. And what is our first term? Our first term here, which is A, it is 1 plus I to the power of negative 1. So now we are going to use sum of geometric series, whereby they're saying sum of n n terms for geometric series is equals to A into 1 minus R n over 1 minus R. So now in this case, we have our common ratio as 1 plus I to the power of n, and also our first term, it is 1 plus I to the power of negative 1. So now substituting this, so now it means we are going to have the present value equals to what? X. So now what is sum of geometric or what is the sum of our geometric series? It is first term, which is 1 plus I to the power of negative 1 into 1 minus, what is our R? Our R here, it is 1 plus I to the power of negative 1. So we must raise this to the power of what? N, since where we have n terms, all divided by 1 minus our common ratio minus 1. So now simplifying this further, we are going to have, well, we are going to have present value equals to what? Equals to X into, so now we can say this is the same as what? It's the same as, okay, let me rewrite our numerator first. So it will be 1 minus, so multiplying this, remember the law of exponent says a power raised to a power, it means we are going to multiply the exponent. So it will be minus 1 multiplied by minus 1 multiplied by n. So now this will become 1 plus I to the power of negative n. So now this 1 plus I to the power of negative 1, it is the same as 1 divided by 1 plus I to the power of negative 1 into, so now remember we had this denominator before, which is 1 minus 1 plus I to the power of negative 1. So now let's simplify this. So now it will be equals to X into, so now we have this denominator 1 minus 1 plus I to the power of negative n, all divided by our denominator. So we multiply this by 1, so this will be the same as 1. So now we have a negative 1 on our denominator as the exponent, so it is the same as taking this to the numerator. So now it will change, our exponent will change sign from negative to positive, then it means it will be 1 plus I, so we multiply it by 1. So now multiplying this by 1 will give us 1 plus I. So now let's multiply this 1 over 1 plus I to the power of negative 1 by what? By 1 plus I to negative 1. So now this will give us what? This will give us 1. So now simplifying this, it will be equal to x into 1 minus 1 plus I to the power of negative n all over. So now as you can see, now we have 1 minus 1, then this one cancel out this one, then we are left with what? We are left with I. And please note that in this formula, our I, it is the effective interest rate. So I, it is our effective interest rate. So that's how we got. So that's actually the logic behind this formula for calculating the present value. So now this formula, well, it is crucial for determining how much a series of future payments is worth today. So it is widely used in finance for valuing loans, investments, pensions, in any scenarios involving regular payments over time. So yeah, that's how we derive this formula.